Well, welcome friends to my YouTube channel Sommo Physics. Yesterday I discussed about geostationary satellite and its velocity and time period of revolution and few uses of geostationary satellite or artificial satellite. Now in this video I am going to tell you about the energy of an artificial satellite, that is binding energy of an artificial satellite. Okay, so let's proceed. Now we know that if a satellite of mass m revolves around the earth with an orbital velocity v in an orbit of radius r, okay, then what will be its kinetic energy? Its kinetic energy will be half m into v square. Okay, if an artificial satellite of mass m revolves around the earth with a orbital velocity v in an orbit of radius r, then its kinetic energy will be half m v square. And we all know, previously see we see that v square is nothing but g into capital M by r. Okay, what is capital M? That is mass of earth. When we derive the expression of orbital velocity of an artificial satellite, we prove it, that is v equals to square root of gm by r, where capital M is the mass of earth. So what we get, we can write here g into m divided by 2r. So this is the expression of kinetic energy of the artificial satellite. Now what would be the potential energy of the satellite? We all know that potential energy v, this is nothing but the amount of work done in taking the satellite from infinity to a certain distance, say r. Okay, so that means integration of infinite to r, force into distance. And what is force? G into m by r square into dr. So this is the expression of potential energy of the satellite. And if we simplify it, then we get minus g into m by r. Okay, so this is the expression of potential energy. Now what would be the total energy? My total energy would be E. This is equals to T plus V. So that is simply G into m by 2r minus G into m by r. So we get minus G into m by 2r. Okay, so we see that the total energy of the satellite is negative. Okay, and the negative sign has a significant value. uh, what is the value? Now we all know that due to the collision with the atmosphere, the total energy of the satellite must be decreases. Okay, that means minus gmm by 2r decreases. So if minus gmm by 2r decreases, then gmm by 2r increases, then gmm by 2r increases. Okay, okay, due to the collision with the atmosphere, the total energy decreases. That means minus gmm by 2r decreases, and minus gmm by 2r decreases means gmm by 2r increases. Now if gmm by 2r increases, then r decreases. Okay, r decreases. And if r decreases, then h, this is equals to small r minus capital R, so h also decreases. Okay, so we can easily say that due to the collision with the atmosphere, the total energy of the artificial satellite decreases. As a result, it comes closer to earth surface. Okay, it comes closer to earth surface. So the satellite come closer to earth surface. Okay, this is the significance. This is the significance. Since r is decreasing, the satellite comes closer to earth surface. Okay, now here we shall discuss about an important factor or important uh, term which is known as the weightlessness. What is it? What is weightlessness? We have to discuss about weightlessness. Okay, an important term arises here. This is weightlessness and we explain it. Okay, so let's proceed. Now the question that arises is that why a person or an object inside an artificial satellite feels weightlessness or are in weightlessness condition. Why? What is the reason behind it? Let's see this. Now suppose this is earth. Okay, suppose this is the earth and this is the artificial satellite. Okay, suppose this is the artificial satellite. Okay, this is the artificial satellite and this is the center of earth. Suppose the distance is say smaller. Okay, now if the mass of earth is capital M and the mass of the satellite is small m, then we all know that the earth is attracting the satellite by a force gmm by r square. Okay, gmm by r square. So this force acts in the downward direction. Now there must be an upward reaction of the satellite. There must be an upward reaction of the satellite, which we say r. Okay, earth is attracting the satellite by force gmm by r square in downward direction. Now there will be a upward thrust or upward reaction force r. Okay, now what is the resultant force? The resultant force will be gmm by r square minus r. Okay, now this resultant force will provide the necessary centrifugal force to rotate the satellite around the orbit. So this resultant force will provide the necessary centripetal force, which is nothing but mv square by r. Okay, so what will be my r? My r will be g into m by r square minus mv square by r. Okay, so if we simplify it, gmm by r square, now what will be my v square? We all know that the orbital velocity of an artificial satellite is gm upon r, so this is simply 0. Okay, thus we see that the upward reaction force is always 0. Upward reaction force is always 0. That's why any person or an object inside an artificial satellite is in weightlessness condition. This is called weightlessness. Okay, the upward reaction is 0. Upward reaction force is 0. This is called weightlessness. This is called weightlessness. Weightlessness. Okay, now first of all I repeat again, the earth is attracting the artificial satellite in the downward direction. Now there must be an opposite reaction force which we call r. Now the resultant of these two forces is this. Now this force is providing the necessary centripetal force to the satellite to rotate. So the equation of motion is this, and we already know that the orbital velocity of an artificial satellite is gm by r. So substitute gm by r instead of v square, and simplifying we get r equals to 0. So that's why any person inside a satellite is in weightlessness condition. This is an important question, so remember this. Okay, now in my next class I will discuss few problems regarding the central force and planetary motion. Okay, so if you don't subscribe my channel, then kindly subscribe it and share it to your friends. Okay, thank you.